this little bio break, and I am happy to announce you the next speaker. So we have Alexa Joyce, who is our Future Ready Skills lead and responsible for this area for Europe, Middle East, and Africa from Microsoft. Alexa, welcome and thank you for joining us today.
Thank you, Vanya. It's an absolute pleasure to be with you for this Showcase Schools Summit. And it takes me back to the last one in Estonia and how different it is to be connecting at distance, but still able to have these very rich conversations and insights from amazing experts and educators around the world. So it's a real pleasure for me today to talk about how we need to think about transforming computer science education. And I think many of you within the Showcase Schools are probably already at the leading edge of some of this transformation. I want to take us back to a topic that we looked at in the last Showcase Schools Summit when we talked about the arrival of the fourth industrial revolution. This is really the key driver which is changing our societies so radically in terms of disruption of the way that we live, the way that we work, and the way that we relax and have fun. And this is also creating a massive change out there in the world of the future job market and where today's graduates are going to find themselves as school children move from their school career through to their future workplace. And this shift in demand is really, really immense. And we're seeing that this fourth industrial revolution is creating an erosion of those traditional jobs which required repetitive activity, low cognitive skills, low creativity, and being replaced by new types of jobs that require more sophisticated ways of thinking, of reasoning, of reflecting, much more emphasis on social and emotional skills and being able to collaborate, being creative, being able to problem solve. But above all, huge growth in the need for technological skills as we see that even the most traditional industries are starting to rapidly transform. And this has obviously really been accelerated by the impact of COVID, where, you know, even in my local village, the butcher shop now has an online ordering system and digital payments, digital collection, whereas prior to COVID, that was just not necessarily the case. So at Microsoft, we want to really take ownership, take our responsibility as a company to ensure that we play a role in helping ensure that everybody, every student, every teacher, every single person on the planet has the opportunity to get the digital skills that they need to succeed, get the digital skills that they need to participate in a digital society and a digital economy and be able to be successful in what they do in this new digital world. And as I mentioned, COVID has dramatically accelerated digital transformation in schools. We often say that we've seen the same amount of transformation in 6 months since the arrival once the COVID pandemic hit versus the prior 6 years in terms of integration of technology and digital pedagogy taking place in schools. But equally, that same type of change is happening out there on those job markets that students are going to find themselves faced with as they graduate from school. And so when we think about how we can equip our students with the digital skills that they need throughout their school and higher education lives, we at Microsoft have been working really hard to create the right types of programs, the right types of solutions, the right types of tools to help you and to help your students be successful with technology and go beyond being a digital consumer, which we know young people are incredible digital consumers, probably the most digital consumers within the whole of society. But we still see that there is this fallacy of the digital native, that actually students are not necessarily able to transfer their amazing skills in digital consuming into digital production or building the digital tools of tomorrow. And so that's why schools and teachers are so critical in helping enable that digital skilling journey for students to make them become productive and active in their use of technology rather than passive. So when we think about what that journey would look like, when we think about primary education, it's really about sparking curiosity, about opening their minds up to the idea of science, technology, engineering and math subjects, that these are topics that can be exciting, challenging, fun even, and can help them to solve interesting challenges in their lives and in the world. And so we embed within our tools for students the opportunity to be playful, to be creative, and to use gamified platforms like Minecraft to dig into computer science and STEM learning. And as we get into secondary education, we can build on top of that enthusiasm to help start the process of moving young people from those more playful tools into actually what are the kinds of high-level, high-spec digital professional tools that they might encounter in the workplace or in university. So getting them the opportunity to work with the cloud, to work with AI, to work with machine learning, and to introduce them to all of those tools already even at the upper end of secondary level. And then once they graduate, then we want to move on obviously to getting deep into those kind of technical skills that can help them succeed in the tech industry, but also embedding technology across multiple other subject areas, because even in something like history or social sciences, digital research tools are becoming a crucial part of being successful at those types of subjects. So all of this points to thinking about how do we tackle computer science across the curriculum. And when we think about computer science across the curriculum, there's various models which are used. One is to have a dedicated computer science topic. One is to have a computational thinking skill embedded across the curriculum. Some other countries still focus on digital literacy. But what we see across the world is that there is still insufficient interest among students in computer science at tertiary level. And the reason when we survey and we talk to students about why that is because they don't have a compelling experience of what computer science looks like or means to them in primary and secondary education. And so there's really a need to rethink how we look at teaching and learning of computer science in primary and secondary schools. It's really hard. Firstly, we as the tech industry make life very, very difficult for schools because we keep changing what technology is and how it's built and how it's deployed. So it's very hard to keep curriculum up to date. We also see that many curricula across the world are not connecting with a wide base of students. So there's a very typical male and pale profile in terms of who gets interested and excited about computer science at school. And when we look at new methods and new approaches, which are more hands-on, which are more problem solving, rather than what I call recipe book computer coding, we see that a wider group of young people are excited about what computer science has to offer. And this is really important for us as societies because we need to build those tools of tomorrow in a way which is inclusive and equitable. And the only way we can do that is by having inclusive and equitable education in computer science to create a more diverse profile of professionals as they graduate from school. We also need to ensure that we think about clear progressions through computer science topics and knowledge building of the concepts over time. We still see a lot of countries, a lot of locations doing kind of hour of code or computer science week, which are great initiatives, but they may be limited to just that period of time within the school curriculum. And so when we look at the research, what we see is that those countries that have a full-scale computer science curriculum have more time to dig into the concepts, typically than those who embed it across the curriculum. And it also needs to be framed in terms of computational thinking, that wider skill set, rather than simply thinking about programming or coding. So at Microsoft, we decided that we would put together a toolkit to help education systems, to help schools, to help teachers think about new approaches to computer science education. And so we brought together some experts from Microsoft, but also from outside Microsoft to help to think about this issue. And we also did it because so many people were asking us for this. We had a lot of organizations come to us saying, what do you recommend? So we built this curriculum framework, which guides a progression through the lifetime of the students over what they should be learning and how they could be learning, brings in the huge amount of resources that we have at Microsoft. We typically launch every couple of months some brand new teaching and learning materials in different aspects of computer science. We have emphasized problem-based learning to make sure that it's really engaging and hands-on and develops that thinking methodology around computer science rather than just being able to program or being able to understand a technical concept. And we've really structured it in a very future-looking way so that we've brought in cutting-edge topics which we don't typically see in primary and secondary curriculum yet, like AI, like data literacy, like the Internet of Things, blockchain, cybersecurity, so that we can ensure that this curriculum is more evergreen. The other key aspect that we have taken care of as we built this curriculum was the social aspect. So the research that Microsoft has done, but also other academic institutions around the world have done, indicates that for non-traditional groups in computer science education, that it's really critical to underline the power of computer science to solve big societal challenges. And the societal challenges which are laid out in the Sustainable Development Goals are of critical importance. They're very well known among teachers and students. And so we've created many of the activities and problems and projects and challenges within the curriculum while thinking about the Sustainable Development Goals. And just to give an example, we used some of the materials that's available within the curriculum very recently to organize, together with UNESCO, a hackathon for girls, looking at how they could harness AI for the SDGs. And we saw some amazing projects coming out of that, including one of the winning projects from Spain, another winning project from South Africa, looking into really interesting topics like how could you use AI and machine learning to be able to monitor the populations of endangered wild dog species in South Africa. So what's in the toolkit that we've built? We have a set of guidance. So there's 4 key documents which can help you as you think about how you want to reboot computer science teaching and learning in your schools. First of all, is a white paper which sets out what are the challenges and issues and what does the research tell us. Really digs into the detail there, which can help you have a rationale for change. And then it goes on to explain the principles and the concepts as how the curriculum is built. So what are the pedagogies, what are the approaches, and so on. And then finally, the curriculum itself, which maps out all of the different topics with different recommended learning materials that can be used as part of the curriculum. And there's also an Excel master plan, which is an Excel sheet where you can move blocks around, adjust it, localize it, reuse it in ways that make sense for you. I think I want to underline as well, it is aligned to a number of international standards. We've aligned the different components of the curriculum to the Computing at School standards, which come out from the UK, as well as the US computer science teaching standards. But we've also had to go beyond them because there are so many cutting edge topics in there which are just simply not yet reflected in other international standards. So to give some examples of the kinds of tools and materials that we're advocating for usage during the implementation of new computer science curriculum, firstly is Minecraft. And we have a complete short curriculum for computational thinking that's available as a Minecraft package for you to use, including teaching and learning materials, pre-built worlds that can be injected. And you can see here, this is the example of the code connection tool, which is available within Minecraft, which enables students to be able to program a bot within the Minecraft world and to get to figure out how to be able to express themselves using, first of all, block-based coding, but then they can also segue into JavaScript and Python, depending which one they choose within the code connection tool. And it's really compelling for particularly even young kids. Typically, you know, students get fed up when they're building a big structure, just placing blocks and blocks and blocks before they can actually get around to doing something exciting in the environment. And explaining that they can actually program an agent to help build their structures before they get to do their cooperation in there is something which they find really compelling and really interesting. Now, we know that Minecraft can seem a little bit tricky for teachers and even for those who may be technology fans, that Minecraft seems like it has a higher learning curve. We got a ton of great learning materials available on the Microsoft Educator Center, which dig into the Minecraft worlds. There's also our Minecraft mentor teachers, and we're going to have a dedicated Minecraft Academy, which we'll be communicating almost imminently to you about, which will be open for MIEs to join to get certified as Minecraft teachers as well. So we're trying to bring that barrier down to make it much easier. One of the other key aspects of the primary school level materials is also getting computing out of the virtual world into the hands-on world. And we have partnerships with amazing physical computing partners like the Microbit Foundation, who help to work with us to create materials which can enable creating hands-on projects in computer science. And we have a virtual block-based coding environment which can be connected to these physical computing tools. And the benefit of that is, first of all, you have a virtual microbit within the MakeCode tool. So if your students don't have microbits to take home, they can carry on working on their projects from home. And so you can continue doing remote learning with the microbit, even if students are not in school, with that piece of the chipset that they can use to actually work on. And we see some really amazing applications being brought forward. I was just talking very recently with one of our MIEs from Slovakia, who's been building wearables with microbits together with her young female students, and seeing that having a really motivational impact on her students. So we can build on those really fun block-based coding types of experiences as students get into secondary school by helping them to segue into professional level tools for computer science. And one of the key things which I want to highlight is Microsoft Learn. Microsoft Learn is actually, initially was the platform that Microsoft used for training our own staff. So we know that it works super well, and includes self-taught modules, self-paced materials, online sandboxes, so students can actually get to grips with using technology in a very hands-on way. It's a gamified experience, so you build up trophies and rewards as you go through the program. And there's a dedicated student-facing entry point of the platform, so that students can get to access easily those beginner level materials that can introduce them to creating their very first website, or writing their first code in Python, and so on. And in addition to that, to help educators, we've built a program called the Microsoft Learn for Educators program, as well as an educator landing page for the Microsoft Learn portal, where you can get free Microsoft official curriculum. So that includes presentations, teaching guides, and so on, which you can register to access. And then those can be used together with students in the classroom in combination with the online learning experience on the Learn platform, so that you can have that taught experience with your students as well. And we're seeing real enthusiasm and interest in using this, massive growth since we've launched the educator and student program for this. Because it really helps students to get hands-on with something which is really professional level. I should also add that we have within our offering for students a really great offer, which is that they get $100 of free Azure credit a year, so they can actually start working in real life on the cloud and get to use those tools in a way that are something more like what they will experience in their employment. So what can you do based on all of this to transform computer science in your schools? Well, first of all, you can download the Computer Science Toolkit. You can find the links there, and we'll also pop them in the IM so that you can get your hands on them. We're also going to be making available a workshop that can be done together with school leaders to help you think about your approaches and your strategy for your school. And there will also be an online training course for teachers that you can provide to your staff on MEC as well, which will be coming soon. I think I just want to wrap up by saying computer science is so important to the futures of our students. It's absolutely critical that we work together to make it more inclusive, more equitable, and more engaging for them, to help every single student succeed in their life and in their future work. Thank you.
Alexa, thank you so much for these amazing and very, very cool insights, and thank you for taking the time. And now we are off to our next speaker, Miss Kati Tiainen from Microsoft. Kati, the floor is yours.
Thank you so much. And if you can confirm that you see my slides.
We can see your slides.
Excellent. So good